Good evening, and welcome to the Song of Urania, a podcast about the history of astronomy from antiquity to the present, with new episodes every full moon. My name is Joe Antonini. Well, when I originally set out to do this podcast, I had a plan. I wanted to put out an episode every full moon, but I also knew that putting together an episode was a fair amount of work, so I wanted to give myself some wiggle room for a little break every now and again. Not very often, just once in a blue moon. Quite literally. My original idea was to skip any months that had a blue moon to give myself a month off. Well, I've been doing this podcast now for about 2.5 years, and at long last, this episode is the first time that it falls on a blue moon. Sort of. I'll get to that in a moment. But here we are with a new episode coming out right on schedule, or at least as close to on schedule as I normally am. So why have I broken this promise to myself of rest and relaxation? Well, the whole plan fell apart when I noticed something. Some podcast apps have a feature where they will tell you how often new episodes of the podcast come out. Some do this fairly approximately, and will say if it's daily, weekly, monthly, and so on. But some will actually calculate the average number of days between episodes right down to the first decimal place. Well, the neat thing about this podcast, at least to me, is that even though, as you may have inferred, I'm not always precisely on time with each episode, I do eventually get around to putting out an episode for every full moon. And as a consequence, my variation in the exact time that each episode gets released all gets averaged out. So if you look at the average length between episodes of this podcast, it's now really quite close to the synodic period of the moon. Excluding this episode, since I'm not sure exactly when it'll be done and posted, so far, the average time between episodes is 29 days and 15 hours, whereas the synodic period of the moon is 29 days and 12 hours. Not too bad, given all my irregularities. The interesting thing about this is that if we're just looking at the average time between episodes, it doesn't really matter how far off I am from actually posting on the full moon. All that matters is that I have the same number of episodes as there were full moons over that time period, and that the first and last episodes roughly correspond with a full moon. Any other variation just gets eliminated in the averaging. So, the longer this podcast goes on for, the more accurately you can figure out the synodic period of the moon just from the average time between episodes, which some apps will helpfully tell you. Now, I think that's kind of neat in itself, but more relevant to the history of astronomy, it's a nice demonstration of how early astronomers could measure the period of the moon's orbit to a precision that seems surprising to us today. The Babylonian astronomers, for instance, knew this period to within a second. But to do this, they didn't need to have invented a clock with a second hand, or even need to have a way of determining exactly when the moon was full or new. All they had to do was count the number of full moons they saw for a very long period of time, and then let the averaging sort out the variation. Well, all this is to say that now I'm in this for good, because if I ever skip an episode, this will all be ruined. Nevertheless, I have been going for a while now, so as a compromise to myself, this episode will be on the shorter side, and I'm granting myself the liberty of stepping outside the overall narrative to do an episode on a somewhat more frivolous topic. And as a bonus to both me and you, this will give me more time to read about Indian astronomy before I really have to say something of substance about it. So hopefully it will make for a better informed episode when it comes out. As for what the frivolous topic is, what could be more appropriate for the podcast's first blue moon than the history of the blue moon? Now, today when someone says that there will be a blue moon, they almost always mean that there will be 2 full moons in 1 month, the second of which gets designated the blue moon. But this meaning of the term blue moon is actually quite recent. It sounds like it's some archaic astronomical or astrological term like so many others that litter the field, but at least in popular usage, this meaning of blue moon only started to become common in the late 1980s, and the story of how this came to pass is a bit surprising, so I thought I would devote this episode to telling that story. The research on this topic was begun by the folklorist Philip Hiscock in the early 1990s, who wrote an article where he tried to track down where the definition of a blue moon as the second full moon in a calendar month came from. A few years later, a trio of scholars, Donald Olson, Richard Feinberg, and Roger Sinet, traced the definition back to its origins and wrote an article of their own. So this episode is largely based off of the work they presented in these 2 articles. Well, although the modern technical meaning of a blue moon is quite recent, if you comb through the English literature looking for this phrase, you actually find that the first reference goes back a rather long ways, almost half a millennium. In 1528, 1 year after Henry VIII got the ball rolling on the English Reformation by petitioning the Pope for an annulment, 2 Anglican friars and polemicists named Jerome Barlow and William Roy authored an anti-clerical pamphlet entitled "Read me and be not wroth, for I say no thing but troth." The whole thing is about 180 pages long, and roughly half of it consists of a dialogue between 2 priests named Watkin and Geoffrey. Towards the end of the dialogue, Geoffrey makes the first written reference to a blue moon, and says, quote, "O churchmen are wily foxes, more crafty than jugglers' boxes. To play le jeu de man teached, it is not for naught they feign that the 2 swords to them pertain, both spiritual and temporal, wherewith they play on both hands, most tyrannously in their bonds, holding the world universal. Against God they are so stubborn, that Scripture they toss and turn after their own imagination. If they say the moon is blue, we must believe that it is true, admitting their interpretation." End quote. Now, there are 2 superficially plausible ways to read this line. One sense would be astronomically, that the churchmen say that the moon is blue because they are responsible for fixing the calendar, and some years have an extra full moon, making one of these moons blue. After all, if there's one thing you've gotten from listening to this podcast, it's that throughout history, astronomy has been tied up with determining calendars for religious rituals. So astronomy has been historically associated with a culture's priesthood, and early modern Europe was no exception. But this sense doesn't really fit in with the overall context. The more probable interpretation is that Jerome Barlow and William Roy were just saying a thing that was utterly ridiculous, that the churchmen were making you believe, much like the other tenets of the papal cult. This reading fits in with other early usages of the phrase blue moon. The term didn't really start to be used with some frequency until the 19th century, and even then the usage is almost exclusively in the sense of the modern colloquial meaning of once in a blue moon, or something that happens very rarely, if at all. And since time immemorial, mankind has had need for absurdist phrases to describe things that will seemingly never come to pass, like getting your money back from your cousin Tony. Now, whether or not Barlow and Roy coined the term blue moon themselves, or they were just the first to commit it to writing, is unknown, but there are many other such phrases that show up around the time. For instance, never miss, or in the reign of Queen Dick. One phrase that had particular staying power developed about a century later, and was Tibb's Eve. If you wanted to say that something was unlikely to happen, you said that it would happen on Tibb's Eve. In the early 17th century, English plays started to feature a stock character named Tib, who was a woman of loose morals and provided comic relief. To speak of Tibb's Eve, then, was to imply that there would be a St. Tibb's Day, which meant that there must be a Saint Tib, and hence that this wayward woman had become canonized as a saint. If a child asked when exactly Tibb's Eve was, people would say that it was neither before nor after Christmas, or that it falls between the Old and the New Year. But these things have a funny way of leaping into reality. In the first part of the 20th century in Newfoundland and Labrador, people in the province began to put Tibb's Eve on a specific day, December 23rd. Although Tibb's Eve was originally fictitious, it had always been associated with the Christmas season, since Tib tended to show up in the plays that were popular around Christmas time. Historically, Advent, the 4 weeks before Christmas, was a time of penance, a sort of mini-Lent, so people often abstained from tipple. But as it began to look a lot like Christmas everywhere you went, waiting to break open the Christmas liquor just became unbearable, and Newfoundlanders used the excuse of Tibb's Eve on December 23rd to get into the Christmas spirit a little early. For the more learned, they would use the phrase "at the Greek calends" to speak of something that you shouldn't bet would happen. I'm pleased to say that if you've listened to episode 24, you can now count yourself among this elect group, because in that episode, we learned of the concept of the calends in the Roman calendar, which was the first day of the Roman month, and literally meant register of debts, since this is when the payment on debts was due, and is where we derive the word calendar today. But the Greek calendar had no calends, so at the Greek calends meant never. Well, the idea of a blue moon is not in fact quite as ridiculous a concept as Jerome Barlow and William Roy might have thought when they put pen to paper. On rare occasions, typically after some volcano eruptions or wildfires, the moon can in fact appear faintly blue on the sky. This was reported in 1883 after the eruption of Mount Krakatoa, in 1927 after a monsoon in India, and in 1951 in Alberta after a wildfire, among other cases. The reason that this can happen is essentially the same physics that causes the sky to be blue, but in reverse. When you were in first grade and asked your teacher why the sky was blue, your teacher probably told you all about Maxwell's equations and Rayleigh scattering. That was probably a while ago for most of you listening, so I'll forgive you if you've forgotten the details. And as a refresher, the basic idea is that the atmosphere is full of particles, mostly molecules like diatomic nitrogen and oxygen, but also sulfates and larger particles. To first order, we can treat them all as little spheres of different sizes. As the light from the sun passes through the atmosphere, it interacts with these little spheres. Now, the wavelength of visible light is in the range of 400 to 700 nanometers or so, whereas the molecules in the atmosphere are generally of order a nanometer or less, so the molecules are much smaller than the wavelength of light. Under these conditions, the molecule basically sees the light that's passing through it as a slowly varying electric field. As the electric field starts to build up in one direction, it generates a dipole moment in the molecule. So if the electric field from a light wave is pointing, say, to the right, then the electrons in the molecule will tend to bunch up on the left side of the molecule. As the light wave passes through the molecule and the electric field is now pointing to the left, the electrons will bunch up on the right side. So the passing light wave will generate an oscillation of the charge in the molecule, and an oscillating charge, of course, emits its own electromagnetic radiation. So even though the impinging light wave was traveling in one direction at first, after interacting with the molecule, there will now be a small component that is traveling in other directions as well. So there's a kind of scattering of the light wave going on, and specifically we call this phenomenon Rayleigh scattering. Now, how strongly the light wave gets scattered will depend on a number of factors, but the most important are the size of the particle and the wavelength of the light. There will be an overall factor based on the radius of the particle squared, since this is just the geometric cross-section of the particle, just the area of the particle in space as seen by the light wave. But there's another factor, which is the ratio of the radius of the particle to the wavelength of the light to the fourth power. In other words, if you have a light wave of some frequency, the larger the particle is, the more strongly it will scatter light. This makes sense because a bigger particle can create a larger dipole moment, and so it will radiate more as it oscillates. But we can turn this around. For a fixed particle size, shorter wavelengths of light will scatter more strongly, to the fourth power. So this is why, if the weather is good, the sky is blue. Blue light has a wavelength which is about half the wavelength of red light, so it scatters 16 times more strongly. But wait a second, why is the sky blue and not violet? After all, violet has an even shorter wavelength, so shouldn't it scatter the most and make the sky violet? The reason is that while the sun produces light at all wavelengths across the visible spectrum, the peak of its spectrum is around green, and at shorter wavelengths, the spectrum of the sun starts to get exponentially cut off. In other words, at wavelengths somewhat shorter than green, as you go to even shorter wavelengths, the amount of light the sun is producing gets exponentially smaller. So sky blue turns out to be the sweet spot, where it gets strongly scattered, but the sun also produces a lot of light at that wavelength. So that, or something like it, is probably what your first grade teacher told you all those years ago when you asked why the sky is blue. But Rayleigh scattering only tells us what the sky looks like when the weather is good. It can't tell us what the sky looks like when the weather is bad. Rayleigh scattering isn't the whole story of how light interacts with molecules. It's only valid if the particles are much smaller than the wavelengths of light. Rayleigh scattering is just an approximation of the full theory, which is called Mie scattering. Now, at the other extreme, where the particles are much larger than the wavelength of light, the theory is quite simple, even simpler than Rayleigh scattering. The particles basically just scatter all wavelengths of light equally, since from the light's perspective, the particles might as well be just giant bowling balls. This is why clouds are white. The water droplets that they consist of are on the order of a few microns or larger, much larger than visible light, so all the wavelengths of light from the sun are scattered equally, and they all mix together into white. But Mie theory in its full generality is really needed when the size of the particles is roughly the same as the wavelength of the light. And this is where the really interesting stuff can happen. And of course, by really interesting, I also mean really complicated and difficult mathematically. But one of the interesting features of Mie theory is that there can be a kind of resonance when the wavelength of the light wave is about the same as the size of the particle, actually slightly larger than the size of the particle. In fact, about twice as much light gets scattered at those wavelengths than at other nearby wavelengths. The upshot of all this is that when the atmosphere contains particles that are just under a micron in size, which can happen after a volcanic eruption or a forest fire, they more efficiently scatter red and green light and less efficiently scatter blue light, which is the opposite of what we get from normal Rayleigh scattering. This produces a pinkish or reddish sky depending on how many particles are in the atmosphere, and with all the red light scattered out, the moon can appear blue. But while it is physically possible for the moon to literally appear blue, and it does in fact happen from time to time, this is generally not what people are referring to when they talk about a blue moon. Usually when they talk about it, it's the second full moon in a calendar month. And as I mentioned earlier, this usage is surprisingly recent. It only seems to have become popularized in the 1980s. The folklorist Philip Hiscock noticed it popping up in news articles in the early 90s and started to track down its origins. One occurrence in particular in the early 90s had to do with a blue moon that was somewhat more unusual than normal. Normally, we speak of the full moon as happening on this or that day, but really the full moon happens at a specific time, when the moon is exactly 180 degrees in ecliptic longitude away from the sun. In 1993, there was a full moon that was during the evening of August 31st in the eastern United States, but during the morning of September 1st across the pond in Britain. So that full moon was a blue moon for the Yankees, but not for the Brits, and at the end of September there was likewise a situation where the Brits had a blue moon, but the Americans didn't. Journalists of the time seemed to have been tickled by this situation, and so there were a number of articles on this moon that was blue for some, but not others. But prior to this, Hiscock found that really the first widespread usage of the blue moon in the popular culture as the second full moon in a calendar month came up as a question in the second edition of the board game Trivial Pursuit, which was published in 1986. Now, as it happens, the editors of Trivial Pursuit keep meticulous records of the sources for their questions, presumably to fend off objections from irate players who feel that they were unfairly marked wrong. Hiscock contacted the editors and asked about their source for the blue moon question, and they pointed him to a children's book called Facts and Records, published in 1985. Unfortunately, Hiscock could not track down the authors of this book, and the trail went cold. For a while, his leading hypothesis was that it was what was called a copyright trap. Books which are essentially compilations of facts have historically found themselves in a rather awkward place with respect to copyright law. On the one hand, compilations of facts are plainly useful. Something like the phone book, a map, or a collection of world records is a valuable thing to have, but it can take quite a lot of effort to put something like that together, so there needs to be a good business justification to do that. You need to make sure that you can sell your books. Now, the market is certainly there, people have always needed these things, but the problem is, what if someone else comes along and copies your book? Say you make a map, for instance. You spend years surveying every square mile of the state of Ohio, and after all your hard work, you publish a map of the state. Then, some other guy comes along, copies your map, and sells it for half the price. What can you do about this? The problem here is that on their own, facts can't be copyrighted. The layout of the state of Ohio is not copyrightable. Or just because someone published a phone book doesn't mean that you're no longer allowed to say that the phone number for Pizza by Alfredo is 555-1216. Now, wholesale copying of a collection of facts nevertheless is illegal. I can't just photocopy a map and sell it as my own. But what if the other guy takes all the towns and roads on my map and redraws them himself, maybe using a different color scheme and a different font? How would you know that he was just copying you rather than collecting his own survey data himself? Historically, what the publishers of these kinds of works would do to show that someone was copying their work was to deliberately insert a few fake entries. If you had a phone book, you'd put in a fake number for a fake business. If you were making a map, you'd add in a fake street or a fake town. These kinds of things have various names: trap streets, phantom settlements, mount weasels, and so on. Of course, you'd have to be judicious about where to place these fake things. You wouldn't want to place a fake street in downtown Manhattan because a lot of people would notice. So these trap streets were in little out-of-the-way places, out in the sticks. But, and I think this is on theme with the history of the Blue Moon, sometimes these errors, deliberate or not, have a way of jumping into reality. In the 1920s, the map makers at a company called General Drafting were making a map of the state of New York, and inserted a copyright trap. They invented a small town called Agloe, near the Catskills, which they derived from the initials of the company's founder, Otto G. Lindbergh, and his assistant, Ernest Alpers. O-G-L-E-N-A was rearranged into Agloe. They then sold the rights to their map to a company called Esso, which was one of the successors of Standard Oil and had a chain of gas stations in the region. Esso then printed the maps and sold them at their gas stations to motorists who didn't want to get themselves lost. A few decades later, Esso discovered that, lo and behold, the fictitious Agloe, New York showed up on the maps published by their rival Rand McNally. Caught red-handed. Or so it would seem. Rand McNally protested that they certainly did not copy Esso's maps. They said that Agloe, New York was, in fact, a real place. What seems to have happened is that in the intervening years, after the first map was published by Esso, some enterprising New Yorker built a store out in the Catskills. He happened to have an Esso map and saw that his store was near some town called Agloe, so he decided to call his store the Agloe General Store. Later on, the county government seems to have picked up on this and labeled the area Agloe. When Rand McNally went to the county government to inquire about any place names in the area, Agloe showed up on the list. So what began as something made up to discover plagiarists became real enough that when it did show up on a competitor's map, it was no longer proof of anything. Well, all this is to say that as Philip Hiscock was investigating the origins of the modern meaning of the term Blue Moon, this was his hypothesis for a time, that the editors of the children's book Facts and Records had made it up and put it in there as a copyright trap. And he published his findings to date on Usenet in December of 1990. As luck would have it, though, later that same month he received the latest edition of Astronomy magazine, and it contained a short note by the science journalist Deborah Bird. There happened to be a blue moon that month on December 31st, and she wrote a short note about it, and it contained a reference to an article in Sky and Telescope from 1946. After more investigation, Hiscock realized that Deborah Bird was probably the one responsible for initially popularizing the meaning of blue moon as the second full moon in a month. In the 1970s, she had a radio program called Stardate, during which she had mentioned this supposed fact. Presumably, one of the authors of Facts and Records was a listener to this show, or knew someone who was, and included it in their book, and from there it made its way to Trivial Pursuit, and from then into the minds of millions of unsuspecting Americans just trying to have a pleasant night, vanquishing their opponents with their superior command of useless facts and figures. But what about this 1946 article in Sky and Telescope? Hiscock dug it out and found that the author, James Hugh Pruitt, had heard of it from an earlier edition of the magazine in 1943, which, in turn, had referred to a 19th century edition of the Maine Farmer's Almanac. But without a copy of this almanac, Hiscock could go no further, and he concluded that the usage of a blue moon to mean the second full moon in a calendar month must have been a usage local to New England, or perhaps just Maine. So Philip Hiscock's investigation more or less ended there, but the baton was taken up by Donald Olson, Richard Feinberg, and Roger Sinet. They managed to obtain more than 40 editions of the Maine Farmer's Almanac, going all the way back to its founding in 1819. Now, farmers' almanacs were a staple of 19th century Americana and very influential. If you walked into most any farmhouse in the nation, you would find two books, the Holy Bible and a farmer's almanac. The Bible contained what you needed to know of things spiritual, and the almanac contained what you needed to know of things temporal. A farmer's almanac was critical mostly because it contained forecasts of what the weather would be like in the upcoming year, but it also listed a variety of other facts and figures, and among these would be astronomical data. In particular, the phases of the moon, which was no trivial thing in a time when you had to carry a lantern with you if you wanted any light outside at night. Well, over the years, there have been dozens and dozens of farmers' almanacs published, from Ben Franklin's Poor Richard's Almanac to the American Anti-Slavery Almanac and the New England Anti-Masonic Almanac for those who wanted their almanacs to come from their favored political faction. But one of the more popular almanacs was the Maine Farmer's Almanac, Maine referring to the state, which was in print from 1819 until 1968. In the copies that Olson, Feinberg, and Synott were able to find, they found that more than a dozen of them referenced a blue moon in the year, but none of them was the second full moon in a month. So what did the Maine Farmer's Almanac consider a blue moon to be? Unfortunately, the almanac never published its methodology for a blue moon, but based on the blue moons they had listed, the researchers were able to reverse engineer the algorithm. They noticed that all of the listed blue moons were in the range of the 20th to 23rd day of 4 specific months: February, May, August, and November. This is about 1 month before the season changes, so it suggested that there was a clear seasonal connection. What it seemed to be was that if there was a season with 4 full moons in it instead of the usual 3, the third full moon of the bunch was designated a blue moon. But what made this definition a little bit subtle is that the Maine Farmer's Almanac used a definition of the seasons that is, maybe one could say, simplified, but isn't the modern definition of the astronomical season. The modern seasons are demarcated by when the sun reaches the equinoxes and solstices. When the sun is between the vernal equinox and the summer solstice, for instance, it is spring. But because the Earth's orbit is slightly eccentric, the sun does not move across the ecliptic at a constant rate, so the time it takes the sun to go from the vernal equinox to the summer solstice is not the same as the time it takes the sun to go from the summer solstice to the autumnal equinox. As a consequence, the seasons aren't all exactly the same length, and as I discussed in episode 17, this fact was known all the way back in the 5th century BC by the Greek astronomers Meton of Athens and Euctemon. But the Maine Farmer's Almanac never accounted for this fact. They instead used the motion of the mean sun. That is, they imagined a fictitious sun that moved across the ecliptic at a constant rate. To further simplify things, they also fixed the vernal equinox to be March 21st of every year, regardless of where the sun actually was. Once we use that definition of the seasons, we find that the seasons that contain 4 full moons always have the third listed as a blue moon in the Maine Farmer's Almanac. But why is it that the third full moon gets designated a blue moon rather than the extra one at the end? The reason is that there were a number of especially important full moons that tended to straddle the change of the seasons. A big one, for instance, was the 2 full moons before and after the vernal equinox, since these were intimately tied up with the date of Easter. Easter is the first Sunday after the first full moon after the vernal equinox, so there's always a full moon within the week before Easter, appropriately named the egg moon. The period of Lent, the 40 days of fasting leading up to Easter, really 46 days if you include Sundays, always included another full moon towards the beginning. This one was appropriately called the Lenten moon. But what if one year winter happened to have 4 full moons? Normally, the third full moon of the winter is the Lenten moon, but if you say that the 4th full moon is the blue moon, the Lenten moon will now be before Lent, when everyone is still partying it up, spoiling everything. Similarly, there was a moon before Yule, Yule being the old-timey term for the winter solstice, though over the years it became inextricably conflated with Christmas. But if autumn had 4 full moons, and you named the last one the blue moon, then the moon before Yule would really be the second moon before Yule. Still technically a moon before Yule, but naming the third full moon in the season with 4 full moons, the blue moon, didn't disrupt this delicately balanced system. Incidentally, while I'm on the subject, you may have heard of some full moons getting evocative names like the harvest moon, or the wolf moon, or the worm moon. The names you find in these kinds of lists are largely a rather recent invention of the Farmer's Almanac industrial complex. Native American groups in the northeastern United States did indeed give different full moons throughout the year different names, but these were highly regional. Among the Ojibwe, for instance, they referred to a berry moon and a falling leaves moon, neither of which you'll find in a Farmer's Almanac. But even then, there are differences between the eastern and western dialects of the language. Among the western Ojibwe, the full moon that falls during February is the suckerfish moon, whereas among the eastern Ojibwe, it's called the bear moon. Colonial Americans seem to have adopted some of these names from nearby Native Americans, and had brought 2 of their own over from Britain, the harvest moon, which was the full moon closest to the autumnal equinox, and the hunter's moon, which was the full moon after that. But regardless, these names don't seem to have been very common in American usage, and didn't appear in the Farmer's Almanacs until the 1930s, when, in a surge of popular interest in all things Indian, the Maine Farmer's Almanac seems to have sort of amalgamated a bunch of these names from all over into a single list. Okay, so the Maine Farmer's Almanac evidently used an older definition of a blue moon as being the third full moon in a season that has 4 full moons. How then did we get to the modern idea that a blue moon is the second full moon in a calendar month? Well, the magazine Sky and Telescope had a quiz as a recurring feature in their magazine, and in 1943, one of the questions referred to a blue moon. The author of this quiz, Lawrence Leffler, just said in a rather vague way that some years have 13 full moons instead of the usual 12, and this gives us a blue moon. So the real culprit was James Hugh Pruitt, who 3 years later seems to have read the snippet and then just assumed that the extra full moon that was the blue moon must have been the one that showed up twice in a calendar month. So when he wrote his article about blue moons, that was the way he defined it. Sky and Telescope then made the error official in 1950 when they published a short snippet about a blue moon that was to occur in May of that year, using this definition. Then, a few decades later, Deborah Bird used Pruitt's definition in Stardate, someone heard it and put it in Facts and Records, and from there, it made its way into Trivial Pursuit. And, being a hit board game among the journalistic class, anytime there was a blue moon, using Pruitt's definition anyway, it was trumpeted across the nation. And one thing that helped here was the consolidation of wire services during the 1970s and 80s, which gave regional newspapers a common source for the filler material they were always looking for to pad their pages. And so now, if you ask someone on the street what a blue moon is, chances are they will tell you that it's the second full moon in a month. Now, while this definition had its origins in an error, by this point it's so prevalent that it's hard to really call it wrong anymore. After all, words mean what we take them to mean. As Humpty Dumpty told Alice, when I use a word, it means just what I choose it to mean, neither more nor less. These definitions were not handed to us from on high, so calling the second full moon in a calendar month a blue moon is just as valid as calling it the third full moon in a season with 4, as long as we're clear about which meaning we're referring to. And in the end, if it's what Trivial Pursuit says, by golly, who am I to argue with it? In my book, George Costanza was right to insist that Spain was invaded in the 8th century by the Moops. Well, according to this modern definition, a blue moon happens on average once every 33 months, and this just so happens to be the 33rd episode of this podcast, so we are exactly on schedule. The next blue moon won't be until May of 2026, and so it will be some time before I can take another break from our narrative and spend a little while talking about another frivolous subject. What it will be, I'm not sure yet, but I have nearly 3 years to figure it out. In the next episode, we'll get back to business and return to the main narrative with the topic I promised you at the end of the last episode, ancient India. I hope you'll join me then. Until the next full moon, good night and clear skies.